In this video, I'm going to show you guys how to simplify radicals, and specifically these are going to be square roots. So the first thing I want to do is I want to start off looking at a common perfect square root list. And so our square roots are the square root of 4 is 2, and we're using the positive values of square roots here. The square root of 9 is 3, and we do that all the way up to the square root of 121. And so our steps are pretty simple. We are going to factor out the greatest perfect square root from the list. And then when we look at our variables, we are simply going to divide the exponents by 2. And the reason why we're dividing by 2 is when you have a square root, there's a hidden 2 on the outside of the radical. And if we have any remainders, we are going to leave them in the house, which means if our variables have an even exponent, we're going to divide them all out. If we have an odd exponent, we're going to leave one of that exponential value of that variable inside of the house. Let's take a look at some examples here. So we're going to start with the square root of 49. Well, if you go back up to your list, the square root of 49 is right here. We can take the square root of 49. It is 7. So here we go. I know we're scrolling. So the square root of 49 is 7. That goes on the outside of the house. Now we are going to, because there's a hidden 2, divide the exponent by 2. And I can do that. 4 divided by 2 is 2. And this is my answer. How do I know that's my answer? We can reverse the process. The opposite of square rooting is squaring. Squaring means take the value that you have and multiply it times itself, and that means we can put it back inside of the house. 7 times 7 is 49. And when you multiply exponents, you are adding them. X to the second times x to the second is x to the fourth. And so we know our answer is 100% correct. All right, let's take a look at a second example here. The square root of 48. So if I start with the square root of 48, I go, okay, let's use our list. Where is 48 on my list? Well, my list says that the square root of 48 is right before the square root of 49, which means I have to look at numbers on my list that are below 49. So we're looking at 4, 9, 16, 25, and 36. We need to figure out which one of those numbers is the largest number that goes into 48, and that would be 16. What does that look like? Well, let's come over here. We're going to go the square root of 16 times 3. 16 times 3 is the same as 48. And then we have x to the 12th, y to the 7th. And so we can take the square root of 16. The square root of 16 is 4. That goes on the outside. And so we can draw our house over here. We're going to leave 3 on the inside because we cannot take the perfect square root of 3. Remember our rule, right? There's a hidden 2 right here. That means we are dividing the exponents by 2. When looking at the x, I can say, what is 12 divided by 2? Well, that is 6. So 6, x to the 6th power goes on the outside. But you'll notice that the 7 is odd. 2 goes into 7 only 3 times evenly. So we can say y to the 3rd. But that means we are going to leave a remainder on the inside. And so our answer is this guy right here. Let's look at another example. So now we have our square root of 72. Let's figure out where that is on our list. So 72 is between 64 and 81, right? So the square root of 72 is right here. That means we're looking at all the square roots less than 72. So which one of these numbers here on our perfect square root list, 64, 49, 36, 25, 16, 9, and 4, which one of those values is the largest number that goes into 72 evenly? And that would be 36 right here. Why is that? Because when we factor this, we do it like this. 36 times 2 is the same as 72. Then we have x to the 5th, y to the 8th. We can take the square root of 36. The square root of 36 is 6. That's going to go on the outside of the house. we're going to leave the 2 on the inside. And don't forget about our rule, because there's a hidden 2 here. We're going to divide the exponents by 2. Remember, if they're odd, we're going to leave 1 inside the house. If they're even, we're going to extract them out of the house, all of them. So x to the 5th is odd. How many times does 2 go into 5? It only goes in there twice with a remainder of 1. And then we jump over to our y to the 8th. Y to the 8th, if I do 8 divided by 2, that is 4. And this would be our answer. Okay, one more here. The square root of 27. Let's figure out where 27 is on our perfect square root list. Let's clean this up here. So 27 is between 36 and 25. So we're looking at all the values less than 27. So we have the square root of 4, 9, 16, and 25. Out of those 4 numbers, which is the largest number that goes into 27? That would be 9 right here. So we are going to factor that out. What does that look like? So we'll say the square root of 9 times 3, because 9 times 3 is 27. And then we have x to the 6th, y to the 9th, z to the 3rd. Okay. The square root of 9 is 3. We can do that. So we'll take 3. It's going to go on the outside of the house. We're going to look right here with that 3, and we're going to leave that inside. Don't forget about our rule, right? We're taking the square root, so all of the exponents are divided by 2. 6 divided by 2, I can do that. That's 3 with no remainder. 9 divided by 2, well, 2 goes into 9 4 times with a remainder of 1. 2 goes into 3 1 time with a remainder of 1. And this is our answer. Thanks for watching.